Hi guys, it's me again. So this lesson is for April the 17th. Okay, so this is our second offline lesson, and I hope you guys are getting the hang of it so from the last time, just the same thing. You should be having your printed notes ready or having pen and pencil and paper ready and to take some notes. Okay, so today's lesson is on Lewis dot structures. And remember last class we learned the different types of bonding, ionic bonds and covalent bonds and polar covalent bonds. And um, and for covalent bonds, covalently bonded structures, they are bonded together because they share pairs of electrons. Okay, so for Lewis dot structures, they actually for all the covalent covalent bond covalently bonded molecules because they do share electrons together. Okay, so you guys should have learned Lewis dot structures a little bit back in grade 9 or grade 10. And if not, we're just going to have a quick review to begin with. And just to have a quick um, review on what are valence electrons. So remember, valence electrons are just the outermost electrons in the outermost shell. Okay, so don't worry about the s and p orbitals here because we kind of jump ahead and skip the atomic theory unit, but we'll go back to it later. Okay, but you can remember from the board diagram, the valence electrons are the ones on the outermost, the most outside shell of the atom, and they are the ones that are involved in reactions. Okay, and I'm just gonna quickly, um, just 1 second. I just need to. How come it disappeared? I'm not sure if I'm still recording or not, if that thing keep on disappearing. Oh no. Is this thing? Okay, I'm having difficulty today. Okay, sorry for the interruption. I was having a little bit technical difficulty, so I was just testing to make sure I'm recording right now. So so to go back to valence electrons, there's a quick way for you to figure out how to count the valence electrons. So remember, so please take out your periodic table, and so remember you guys learned about the different families. So for the first family here, alkaline metals, um, if you remember how many valence electrons they have on the outermost shell, for the alkaline metals, they have one, okay, one valence electron. Okay, and that was the reason why they like to gain that positive one charge because um, they they like to lose that valence electron so that they will have a complete shell. Okay, so one valence electrons, and as we go from left to right, the alkaline earth metals have two valence electrons, and all the way to the right, this one has 3, 4, 5, 6, 7, and 8. And if you remember the noble gases here, they all have 8, well, except helium, they all have 8 valence electrons. So that means they are very stable, they're very happy, so they don't want to gain or lose electrons. Okay, for the halogens, they have 7, so they're just one away from from having the same number of electrons as the noble gases, so they like to gain 1, so therefore their charge tend to be -1. Okay, so by gaining 1 extra, they like to gain a -1 charge. Okay, so that's how we can easily count the number of valence electrons. Okay, so going back to the notes to draw the Lewis dot structures. So if you take a look at here, so sodium, the first one, um, to draw the Lewis dot structure for sodium. Sodium has one valence electron, so all you need to do is just draw one dot, okay? Like this, you have done this before. You can use dot or cross, doesn't matter, okay? So now for oxygen, so go back to your periodic table. 1, 2, 3, 4, 5, 6. Oxygen has 6 valence electrons, just 2 short away from being a noble gas. And so therefore it likes to gain a charge of -2. So oxygen, 6 valence electrons, so therefore you draw 6 dots. Usually I draw them in pairs like this. Okay, 6 dots, and the pairs can be anywhere. Fluorine, just one next to oxygen, so 7 valence electrons. So just draw the symbol fluorine and then draw 7 dots. So for me, I'm just trying out the cross like this. Oopsie. So 7 crosses like this. Okay. So that's how you draw the Lewis dot for just the atom. Okay. So that's just a review, and we're going to learn how to draw Lewis dots for molecules. So here again, we need to remember the rule called the octet rule. Okay, so the octet rule, octa means 8. So 8 is the magic number, is a happy number. It makes the atoms happy. Okay, so all the atoms in their life, they want to achieve to have 8 valence electrons. Okay, so that's the octet rule. And for all bonded non-metal atoms, they like to have 8 valence, 8 electrons. Okay, 8 electrons in the valence shell. So all these ones, we like I said, that we're talking about today, it's to do with for covalent compounds. So we're dealing with non-metals. Okay, so these are only for covalent compounds. So that's why here we're talking about all the non-metals, and they like to have 8 electrons. Now for 8 electrons, we usually translate that to 4 pairs, okay? Because they always join in pairs. They either have shared pairs or lone pairs. And with the exception of hydrogen, hydrogen only needs 2. And if you remember that from while ago when you draw a Born diagram, hydrogen here, hydrogen only has 1 valence electron, right? So this is hydrogen with 1 valence electron, and it likes to resemble helium. So by gaining 1 extra electron, it has 2, and 2, just like helium, it's stable, it's happy. Okay, so for hydrogen, that's the exception to the rule. It only likes to have 2. Okay, so here we're going to move on to how to draw Lewis diagrams for molecules. So again, for molecules, we're talking about covalent molecules. Okay, so for drawing Lewis diagrams, I have broken down in the steps into many steps, so it's easy for you guys to follow. So I'm going to start with using the example of water. Okay, so with water, H2O, so we're going to go through all these steps to figure out how to draw the Lewis diagram for water. So step number 1, we are going to arrange the atom so that the single one or the fewest one in the compound, in the whole molecule, and place that in the center. Okay, so we're going to pick the fewest one or the single one and put it in the center, and the other atoms go around it. Okay, so in this case, we have oxygen, that's the single one or the fewest one. So there's only one, right? So we put it in the center. And then the 2 hydrogen, we just put it next to it. Okay, so we want to draw this so that it's symmetrical. Okay, so like this. And step number 2, we're going to count up all the valence electrons of the atom. And so we're going to calculate the total number of valence electrons. And there's one thing to keep in mind: if the molecule is an ion, we need to, if it's negative, we need to add an electron. If it's positive, we need to take away an electron. Okay, so that's something we need to remember. Now, in this case, water is not an ion, so we don't need to worry about that. So all we need to do is just to count the valence electrons. So for oxygen, we just did that a couple seconds ago. So for oxygen, it has 6 valence electrons. Okay, so just write down 6 here. And hydrogen, we have 2. So 2 times 1 is 2 electrons. So we're going to add them up, and that'll give you a total of 8 valence electrons. Step number 3, we are going to divide the total from number 2 and divide it by 2. So here the goal is to get the number of pairs. Okay, so we always wants to deal with just pairs. That's how they bond. They bond by having shared pairs. Okay, so 8 divided by 2, and that give you 4 pairs. Okay, so these are the only 4 pairs you have. You have to use them all, and you cannot create extra pairs. Okay, so 4 is what you have. Now the next step, step number 4, it says use a pair of electrons to form a bond between each pair of the bonded atoms. So here we want to join the atoms together. Okay, so let's just redraw the proposed structure here. We just think of it as like using sticks, join these atoms together. So we need one stick to join 2 of them together, and we need another stick to join the other 2 together. Okay, so that's how they bond together, by sharing a pair of electrons. So remember, from last lecture, we talked about these lines. We call them shared pairs, okay, or bonded pair. So here I'm just going to call it shared pair. Okay, so that's we used up 2 pairs, and they share between oxygen and hydrogen. Okay, so that's step number 4. Step number 5, like once you bonded the atoms together, now is the time to think about octet rule. Okay, so you need to fulfill the octet rule. So again, octet rule means 8 electrons or 4 pairs. So you need to remember that magic number here. We want to make all the atoms happy by having 4 pairs of electrons, 8 electrons around each atom, with the exception of hydrogen. Okay, so now if we take a look at just hydrogen itself, right here on the side, hydrogen already have a pair of electron. Okay, so remember, hydrogen only wants 2. Okay, so hydrogen has this pair that's sharing between oxygen. It's already shared. It has 2. So these 2 hydrogens are happy. It's already fulfilled what it needs. Okay, but if you just think about oxygen, the atom of oxygen on it right here in the center, it's not quite happy because it only has 2 pairs. Okay, so we want to give it octet rule. How to do that? We still remember we have 4 pairs on hand. We used up 2 pairs, so we still have 2 pairs. So what we do is we're going to put the other 2 pairs as lone pairs on the atom of oxygen. Okay, so now do the counting, right? So again, 1 pair, 2 pairs, 3 pair, and 4 pairs. Okay, so oxygen has 4 pairs of electrons. That's octet, happy. Okay, so all the atoms are happy. We have successfully used up all the pairs of electrons, and all the atoms are happy. All right, so we're done up to step number 5. So step number 6 is for if, only if you cannot fulfill the ideal of octet rule, the ideal of making everybody happy, but with 1 share pair, you're going to try 2 share pairs. Okay, so that means it's a double bond. And then if double bond doesn't work, you could also try triple bond. Okay, so double bond means like having 2 lines, 2 sticks joined between atoms, and triple bonds means 3 sticks. And that's the maximum. Okay, so there's no quadruple bonds. Okay, 3 bonds are maximum. Okay, so you will encounter molecules where it requires you to have like double bond or triple bond and so on. But remember to always start with one bond between two atoms and then try to fulfill octet rule. And if octet rule is not fulfilled, you cannot fulfill it, then you move on to trying double and then trying triple. Okay, so I think we need more practice. So let's move on to go over a few more practices, and then I'll let you go and to give you like time to do your own practices. So let's do a couple examples just on the bottom of the handout. You guys can just write small. It won't take up too much space, I think. So the first example here is NH4 positive 1. So if you guys remember, this is the only positive polyatomic ion, okay, ammonium, okay? So we are going to just go through all the steps here. So step number 1, we try to, arrange all the atoms so that it's symmetrical, so that the single one is in the middle, okay? So nitrogen in this case is in the middle, okay? And then we try to place all the other ones surrounding it. So for hydrogen right here. Step number 2, it says you need to count up all the valence electrons. So here we have nitrogen. So go back to your periodic table, right? So from left to right, 1, 2, 3, 4, 5. So nitrogen has 5 valence electrons. So that's 5. And we have 4 hydrogens. So that's 4. And add up together, that will be 9. All right. Now remember, there's something extra. It's an ion. Okay. So positive ion means it has lost electrons. Okay. So you're going, in this case, you're going to minus an electron. Okay. So 9 minus 1. So that will give you a total of 8. Okay. So and then let's move on to step number 3 right away. We're going to find the pairs. So divide into 2. So 4 pairs, just like before, just like water. So we have 4 pairs on hand. That's all you have. So in this case, this is a pretty easy scenario. We're just going to use one pair to join between 2 atoms. Okay, so just like having sticks and stick them together. Okay. And check octet rule. Okay, so this one should be easy. As you know, nitrogen in the center has 4 pairs surrounding it. So that's 4 pairs, 4 shared pairs, and that's 8 electrons. So that's octet, right? So hydrogen is happy, and just gonna check happy. And then all the hydrogen, they are happy as well because they only need 1 shared pair. Okay, so they're all happy. So we use all the pairs. It's fulfill the octet rule. And the last step for this molecule is to finish it by putting a square bracket around it. Because it's an ion, you need to put the charge on the upper right corner like this. Okay, and we are done. All right, so let's move on to another example. So this time I'm going to do O2, oxygen gas. So oxygen, so only 2 atoms, right? So step number 1 is not really useful, but we're just going to put them side by side like this. Okay, and then let's count valence electrons. So oxygen from before is 6. So 2 times 6 equal to 12. Okay, 12 valence electrons. Now we're going to divide it by 2. So therefore, it's 6 pairs. So that's what you have. You have 6 pairs on hand, and you want to use them all. Okay, no extra. That's all you have. You can like make up, like, oh, say I want to have 7 instead. You can't. Okay, you only have 6. So 6 is all you have, and then you want to use them all to make both oxygen atom happy. Okay, so let's start with one single bond. So now single bond, right? So let's join the 2 oxygen atom together. So 6 pairs minus 1 pair, I have 5 pairs left. Okay, so I have 5 pairs left. How am I going to put them and to make both oxygen happy? So let's give it a try. So what I can do is I can put 3 lone pairs on one oxygen atom, right? And then I put 2 pairs on the other oxygen atom. So as you can see in this case, I used up all 6 pairs. So there are 5 share pairs and one, sorry, 5 lone pairs and 1 shared pair. Okay, so that's 6 pairs. Okay, but are both oxygen atom happy? So for the oxygen atom on the left-hand side, it has 1 pair, 2 pairs, 3 pairs, and 4 pairs. So the one on the left-hand side here, it's quite happy because it has 4 pairs. Now let's count the one on the right. I have 1 pair, 2 pairs, and 3 pairs. So this is sharing between the two. So only 3 pairs. And so this one is unhappy. Okay, so what does this mean? This means we have to move on to step number 6. So step number 6 says if you cannot fulfill the ideal of 1 share pair, now you need to try a double bond. Okay, so as you can see here, it's the one on the right hand side is not happy. So we are going to, this is the wrong molecule. So we're going to try 2 share pairs. That means a double bond like this. Okay, so again, I have 6 pairs minus 2 pairs. Now I have 4 pairs left. Okay, 4 pairs. So 4 is easier to share among the two. I'm just going to put 2 pairs on each of the 2 oxygen. So now check, are they happy? Are both of the oxygen atom happy? So this is quite obvious. Let's do a count. For the one on the left, I have 1, 2, 3, 4, right? This is a double bond, so that's 2. Okay, so 2 plus 2, that's a happy atom, right? Happy. And I also do the one on the right, 1, 2, and then plus the 2 in the middle, that's 4 as well. So 4 means octet. Octet means happiness, right? So this is the correct Lewis diagram for oxygen molecule. Okay, so oxygen molecules are bonded together by a double bond. So they have a one double bond and have lone pairs, two lone pairs on each of the atom. Okay, so we are done. That's the correct um, Lewis diagram for this is the correct one. Okay, for oxygen. Let's do one more before we end today. C2H6. So step number 1, we're going to put the fewest one in the middle. So in this case, the fewest one is the C2. So we have 2 carbons side by side like so. Okay, and then we're just going to put the other one surrounding it. So again, you are going to try to make everything, oh, what's going on with my screen? Sorry about that. Make everything symmetrical as you can. Okay, so 3 each, like this. Okay, step number 2, we're going to count the valence electrons. So 2 carbon, 2 times 4, 4 each. So that would give me a total of 8. I have 6 hydrogen, 6 times 1, that will give me a total of 6. Okay, so let's add them up, 14. 14 valence electrons. And we're going to divide them in pairs. Okay, so we always wanted to deal with pairs. So divide it in 2, so that will give me 7 pairs. So in this case, 7 pairs. So let's use them all and try to put everything, stick everything together. Okay, so I'm going to put one between carbon and carbon, and I need to join all the hydrogen together. So that's 4, 5, 6, 7. Okay, so I used up all the pairs, and let's check octet. So that's the key thing to remember. Okay, you can't just say, oh, I used up all the pairs, I'm done. Make sure you always check octet at the end to make sure all the atoms are happy. So let's check carbon first. Okay, so as you can see, hydrogens are quite happy because each one of them has one share pair. So hydrogen is happy. And what about carbon? Carbon, one pair, two, three, four. So four is what they like. Okay, octet, same as this one. This one also having four share pair as well. So they are all the atoms are happy. Okay, so that's the Lewis diagram for C2H6. That is actually yeah, organic compound called ethane. So that's all I'm going to talk about today. So right now, like I said before, you need lots of practice. So I have put a homework worksheet that looks like this on underneath on the page where you find this PowerPoint. So it's covalent bonding. So there are like 6 exercises here, but on the bottom here, can you guys see here on the bottom? Also try, make sure you guys try, oopsie, try all these ones on the bottom, and you need to have a piece of paper. Okay, so you need lots of space to draw all these diagrams. This little guy is a 3 C3H8. Okay, so I hope you guys can see that. Um, and and I will put up the answers sometime next week. So I'll give you guys time to try them. So you don't need to submit these ones. I will put up another assignment number 3 next week. So I think I already updated that on our Google Calendar, so you know what is coming. So assignment 3, I'll put that out next week. And for now, just do lots of practice on the worksheet I'm giving you today. Okay, so I hope you guys are okay, doing well and getting lots of rest and adapting to this online learning environment. I know like we are all learning together. We are all trying to cope, and we can get through this, right? And you guys just take care and take it slowly. Don't stress out. Like, right now we are mostly just doing some learning and practicing. There's no tests and quizzes in sight, so just take it easy, but keep learning. Don't think, oh, this is not for Mart, so I'm not doing it. I mean, this is something that's important. If you guys are going to do more chemistry in the future, this be able to draw Lewis diagram is very important. So I won't be teaching everything that I normally would be teaching you guys um, in this online environment, because due to like short of time, and also like I don't get to see you guys face to face, is some just just hard to cover everything. So, but I will for sure pick up all the key topics that you need to know from Chem 11. So just, get, follow along with me and work hard. And I think most people like enjoy drawing Lewis diagram. It's kind of fun, but also challenging. Let me warn you, like sometimes you'll be like, this is, like how do I figure it out? So the key thing to remember, it's octet. Okay, use up all the pairs, but also you need to remember octet rule. Okay, so that's it for now. Um, I will talk to you soon. Bye.